Now to the technology. So if we want to emulate these two ways of thinking, what do we need? Honestly, for the muscle memory, the right emulating component is to train a model. Why is it to train a model? Because then you get the fast, you get the relatively cheap, and you get this thing where the amount of information doesn't matter. The way we implemented this, let's take us to a very, very concrete example, and I may even share some visualization here to explain it. So our reflex, that's literally how we call this mechanism, because that's what it is built to resemble, is done the following way. First of all, the job we'd like to do here, a security signal comes in. We would like to go ahead and provide, in addition to analysis provided by an opinionated, trained solution managed by our security operations, we would like to develop a muscle memory, a gut feeling that is unique for an organization. How does that work? We take, first and foremost, reflex-less signals that constitute to a good, best industry practices investigation, and then they undergo specific investigation in your organization by your dedicated automations, bespoke agents, sometimes even analysts. And then one of the following three things, and three things only happens. One, maybe after a deep investigation, you confirm the result and you say, oh, wonderful. The system told me it was a true positive malicious thing. What do you know? Turns out it is. Good. We call that a bronze data point, something that signifies confirmation. Slightly worse for this particular signal, but way better for learning. What happens if, after a deeper investigation, you reach a conclusion that the initial verdict was incorrect? No, this is not a true positive. This is actually a false positive signal, nothing to write home about. Perfect. That is actually a much bigger learning opportunity. This learning opportunity is called a silver data point. Best, and the best thing we could all hope for is not only that somebody tells you that, yeah, this verdict is incorrect, but they also explain, bring evidence, point at existing evidence, showing why. This is a gold data point. Now, how do we turn these silver, bronze, and gold data points into learning? Learning in this context begins with us training, post-training, if we have to be very, very exact, an encoder model on the specific sources of an alert, types of actions, tiers of analysis, etc., that the organization has. How do we do that? We build a document, JSON or whatever format, that has all the details of alerts in it. Where did it come from? Enrichment of all entities involved, users' roles, devices status, all actions taken, all comments made, all evidence attached. Encoder model, unlike models that many of us work with on a daily basis, it does not provide its output in a natural language. That's the job for decoder models. Encoder models creates a feature vector, like a comma delimited list of a lot of floating point numbers. Exactly how many actually depends on the model architecture and the amount of parameters. Could be 128, could be 256, could be more. The meaning of that vector for every given document is sort of like the understanding that the model gives. Why do we need to train a model specific for each and every organization and each and every environment? Because honestly, yeah, sources of alerts, their sort of like combination, types of actions that people are taking, operational practices are truly different. Now, what does it help us? So we get these alerts, we translate them into really big vectors. Now we can actually train a classifier neural network to go ahead and say, okay, if this group, and I'll draw dots in a two-dimensional space, naturally it's slightly more complicated in a 256 dimensional, but never mind.
Okay.
So let's say this group represents all alerts that were deemed as true positive malicious by our analysts. Okay. Let's say this other group in here in the corner, that's the false positive alerts. and somewhere in here, there are benign alerts. Now, and next alert, I'll write it in green, and this diagram comes in. Naturally, it will undergo analysis, it will come up with a verdict. But now having this trained encoder and a classifier neural network allows us to position this green dot, say, here, and see that, how interesting. It looks way closer by its different properties to the, true positive malicious than to false positives or benigns. So this is the equivalent of this gut feeling, knee-jerk reaction, and so on. Now, why do we need it? Honestly, it affects how trustworthy, consistent the verdicts we see as being, and serves as a risk score to our ability to go ahead and do something about it. Think of your private life, Tony. Haven't you ever faced a decision where, you know what, both your head and your heart told me I should go for it, and how happy you were to go ahead and do it, versus the head tells me this, but no, the heart tells me I need to do the other way. Make sense?
Yep.
Similar here. Now that is an equivalent of a heart, and that is one type of learning. Now let's talk about the head learning, because that one also exists. Same idea. Alerts go in. Again, with or without the gut feeling, they get assigned a certain initial verdict. They undergo, again, agentic, deterministic, manual work, get resolved with a verdict. Now, smart people learn by building patterns, building associations. And these patterns and associations are specific to the domain they're learning. Smart and experienced security analysts, right? They think in the dimensions of an attack, potentially MITRE attack tactics and techniques involved, potentially certain observables, etc. So we emulate that way of thinking by creating a very unique, specific to the type of a attack being involved here, index. Why is that important? It is important because, when you learn something, the efficiency of learning is measured by, when the time comes, how quickly can you pull this from your memory. So your ability to go ahead and say, okay, I'm now dealing with a green alert. The previous one was red. How quickly can I pull the relevant precedents? How quickly can I recall them, right? And then figure out, oh, okay, how relevant are they? Are they exactly the same? Are they the same but, and so on, and create this head. So what this actually drives is both mechanisms, just like in real life, right? The head and the heart work in tandem. And for every alert being evaluated by the system, in addition to what a disconnected from your environment thing thinks it is, you get a reflex and you get the recall. And now let's talk, because if all three tell you the same thing, your confidence to go ahead and deploy containment, eradication, etc., fully autonomously should be very high. If they disagree, this is where this reconciliation comes. So hopefully, I know it was a short question and a very long answer, but you see where I'm starting to distinguish between just having a memory and actually learning. Does that make sense?
Yes.
Now, imagine, and again, it's not an imaginary thing, what if we could learn, not from experiences that you and I are having right now, but what if we could do proper learning based on something that happened before us, right? And we humans definitely try to do this thing, right? You don't have to experience every single bad thing yourself in order to learn that they're bad and not do it. Honestly, with these mechanisms in place, a similar paradigm can be emulated because, usually when we deal with security operations, we come into an organization had some sort of a system of record, that they have some sort of a history. And if we can go ahead, pool both the alerts and the history of what was done about it in terms of investigation, in terms of containment, what turned out being the root cause, and so on and so forth, import it in a normalized way, generate both the recollection memories, as well as the reflexes based on that, then suddenly day zero, when this thing comes into functioning in your environment, it is actually already learned with both the right knee-jerk reactions and instincts, as well as enough of a cognitive recollection to go ahead and do things. And this, honestly, is not very possible with humans, right? You bring in a human, that they cannot get someone else's brain dump that were here before them, but this system truly can. And that's what our brain is all about, honestly.